And so if I go to my instrumentation tab here, I've got one channel turned on. I've got a Scatus XS hooked up to my computer, and it's just a microphone on a single channel. One of the cool things that's new-ish, I'd say, in time data acquisition in TestLab Neo is the ability to do some monitoring. You see these different functions, a spectrum map, an average octave spectrum, overall level, octave section, etc. Some things that I can monitor in real time while the data is streaming in. One of these is this dB for sound pressure level method. So I have that turned on. If I click on that, it wants me to say what sort of sound pressure level do you want to calculate. And so you'll see the same list that I have here that we saw in the post-processing options that I was showing you earlier. So if I go to LAF, time averaging method is set to fast, 0.125 or an eighth of a second is fixed. I can't change any of these things. And if I arm my system, I get an overall level. And so I'm tapping on the desk. I don't know if you guys can hear me doing that, but tap, 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 and you see the sound level go up relatively fast. And I'm talking louder than I was tapping on the table when I was doing my setup, so I'm going over my limit here. But you can see when I start talking, the level goes up. And if I'm quiet, then the level goes down relatively quickly. Okay, so that's LAF. If I disarm here, I can change this. Just quickly show you that same thing on LAS. Arm again. And here we're going to have a slower approach and a slower decay. So as I start talking, the level will take a little bit longer to go up. And as I'm quiet, it takes longer for the level to fall. Okay, so this is better for, maybe more appropriate for a more stationary noise. You want to get an average sound pressure level. This one's going to be a little bit less influenced by someone slamming a door or a car driving by if you're trying to record the background noise, that kind of thing. Okay. Now we'll take a look at impulse. And there's no impulse set up here, so I can define my own level. So if I say impulse here, that sets, there's no explicit L impulse, but I can set the impulse here. And this one should take the shortest amount of time to rise and should fall the slowest. So I'm going to clap my hands here. Maybe I'll make these a little bit free here. So if I clap my hands, you see the level goes up very quickly and then falls relatively slowly, or compared to some of the other methods here. Okay, so those are some of the other things. I can calculate some of these other ones here. So if I do LAEQ, that is the averaged sound pressure level equivalent, rather. And so you see I actually get two things here, a small t and a big T. And that is the two different options you have between cumulative and instantaneous. The small t is instantaneous, and that's going to update every sample, essentially, or every increment in this case, which should be every 0.1 seconds. And then the large T is the cumulative. So it's going to take all of those samples that were measured. Okay, so as I show these two, as I start talking, the red shoots up right away and the green will sort of follow that. As I keep talking, the level, both levels will go up, but you see sort of the fast fluctuations of my voice in the red, and the overall sort of average or equivalent in the green is the capital T. So that's the equivalent sound pressure level. The red is the equivalent sound pressure level averaged over every 0.1 seconds. So it's pretty fast in terms of fluctuation. The green level that you see on the screen is if you took all of this sound that's happened since I started, that would be the equivalent sound pressure level of a single number value that represents all of the sound that happened since the beginning. So that's what it looks like in live acquisition.